This is just a video about the basics of logarithms and what they mean and their properties. So when I write log base b of a, what does that mean? So this is the power to which you have to raise b to get a. So if this is equal to c, this means that b raised to the power c equals a. Or b raised to the power log base b of a just gives you a. So it's kind of a way of undoing exponents, like the inverse exponent. So, for example, log base 3 of 9 is equal to 2, because 3 squared equals 9. And let's try log base 4 of 64 is 3, because 4 cubed equals 64. So, logs have some interesting properties. So let's look at property number 1. So log base any b of a raised to the power x is equal to x times log base b of a. So you can kind of bring this x outside of the logarithm. And let's try that with log base 3 of 3 squared, or 9. That'll give you 2 times log base 3 of 3. And log base 3 of 3 equals 1, because 3 raised to the power 1 is just 3. So that means that log base 3 of 9 equals 2, which we already seen before. So that's just an example of one instance in which this property works. So let's underline the property in green. Okay, the second property of logs is that log base b of x plus log base the same b of y equals log base b of x times y. So again, it's good to look at an example. Log base 3 of 3 plus log base 3 of 9 equals log base 3 of 27, which is 3 times 9. Okay, so log base 3 of 3 we already know is 1, since 3 to the first power equals 3, and 3 raised to the power 2 is 9, so this is 2. And 3 to the third power equals 27, so this is 3. So that's just an example of this property working. Okay, and a third property of logarithms is that log base b raised to the power x of a, so you raise the base to a power, is the same as 1 over x times log base b of a. So we can see that with log base 9 of 81 is equal to 1/2 log base 3 of 81. Because in this case, x equals 2. Because we can actually write 9 as 3 squared. So, and let's evaluate this. Log base 9 of 81 is 2, since 9 squared is 81. And that's 1/2 of log base 3 of 81 is 4, because 3 raised to the power 4 equals 81. And we can see that 2 is indeed 1/2 of 4. So that's just an example of property 3. Now, property 4 is the most interesting one. It says that log base b of a is the same as log base d, where d is any positive number of a, over log base d of b. So let's look at an example of that. Let's look at log base 9 of 81 again. And let's let d be 3. Okay, let me rewrite this a little bit lower. We already know this is 2. And that's log base 3 of 81 over log base 3 of 9. And we're just picking d to equal 3. And that's, as we've seen, 4, because 3 to 4 equals 81, over 2. And that's equal to 2. So these are 4 of the main properties of logarithms, and they can all be proved using the definition of a logarithm, which is up here. This definition is very important, and using this definition you can come up with all the theorems regarding logarithms. So if you want to see the proofs for all these properties of logarithms, that will be in a separate video.